Hello, everyone. Good afternoon. My name is Peter Kohl-Landgraf, working at Capital Market Strategy Department, and I will present together with Christian Fries, who is head of model development and risk control department of the DZ Bank, and also professor for financial mathematics at LMU Munich. And today we would like to present two protocols with regard to decentralized settlement, one for securities, one for OTC derivatives. And we will present this at a very functional, detailed level. And the reason why we are doing this is because we are maybe all here today, because we are realizing that capital markets are shifting to a functional, higher functional form of intra-company collaboration and transfers. And this is why software will basically the center of all this. And the core element of broader adoption of this functional form of interaction is existence of software standards. And these standards need to be robust, transparent, and best case to be developed in a collaborative and open source code-based way. So let me start. I will present, let's have a look at the agenda. Smart derivative contract. This is a protocol for digital derivatives. Christian will present a decentralized delivery versus payment for securities. And in the third section, we will touch the added value of open standards again, which I just emphasized here in the beginning. Smart derivative contract is a protocol removing counterparty credit risk. So it's not about only digitizing some existing process. You can see this as a new form of a capital markets-based product. So you can trade this anyway, you've already done so far with other OTC derivatives. But this product has an important distinction. It also a feature, it comes totally as software. So motivation coming from, where we are coming from, what was the motivation to design such a product? OTC derivatives come with complex processes and frictions. And the original intentions, if you look at the plain interest rate swap, they are intended to manage market risk. But now, look at the frictions and the processes. I mean, this is a bilateral contract. You may be a trade with your counterpart over 30 years, and this is subject to counterparty credit risk. And to mitigate this risk, several processes are put in place, also from regulatory incentive over the last 15 years. So we have a collateral process to mitigate counterparty credit risk, but this introduces new friction and new risks. So we have settlement risk because there's no payment netting between the original derivative cash flow and the collateral cash flows. We do have different valuation models to determine the collateral amount at the end of the day, which we need to exchange. So we have a dispute process. And we have actually the counterparty credit risk, counterparty risk of collateral, because there might be the time when the counterparty fails to provide the collateral. So there's an over-collateralization of collateral. So we have the initial margin process in place. And this faces institutions to a larger amount of liquidity risk, because if markets change, these collateral amounts may change too. So, and looking at the interest rate swap, the regulator did exactly what we, maybe if we are all about DLT and decentralization, he did the opposite way. He centralized the post-trade processing. Yeah, he said, okay, there's a clearing obligation to process your derivative over a central institution, namely the CCP. But the CCP introduces a new intermediary into the entire system and is subject to default risk. And this is why we have a default resolution process in place, which we are all obliged to see that the CCP is not subject to default. So look at this, red, right? A lot of processes and frictions and risks, yeah? So would you like to digitize the existing world? I think you wouldn't do that. The better way is to just start from scratch. And this is what we did to rethink the post-trade lifecycle for such a derivative and say, okay, you know what, just try to implement a smart contract which maps an OTC derivative into a digitized form. To do that, we need to have predefined product elements in place which ensure algorithmic processing. So fully Turing complete, fully determinism. This is the way we need to do it. And now at DZ Bank, we did this experiment twice. So we traded this product as a new derivative together with Bayerische Landesbank in 2021, 2022 with Union Investment as a new form of the derivative with, as I said in the beginning, being a software which was basically maintained and developed together on a collaborative base and being maintained on a distributed ledger based infrastructure. Design elements. We have a digital trade format developed, so no contract risk anymore because the contract elements are digitized and stored immutably on chain. We have a valuation model, part of the OTC contract, so actually code is part of the law, so no disputes anymore when determine the settlement amount. We have no collateral process in place because settle to market feature replaces it by saying we have the exposure of the derivative net present value to be settled at each day, such that the derivative shows no exposure. We have no counterparty credit risk, and because, as we all know, smart contracts can act as digital escrows, and we put a pre-funding mechanism in place which guarantees the settlement each day. And finally, if a counterparty is subject to default, then there's a pre-termination feature in place at which pre-agreed terms the contract can be ended without any closeout risk. So to show you the mechanics shortly, you see we have the trade internalization. Both counterparties need to pre-fund. Yeah, this is basically relates to the smart contract world where we pre-fund some amounts to a smart contract or digital escrow. This gets checked by the software. Both counterparties trade this derivative, yeah, according to all the rules which apply. And then the digital process, post-trade process starts. We have the valuation being maybe conducted twice or several times intraday. We can do this intraday only. We will determine the settlement amount, which is guaranteed at maximum to the margin buffer, which is pre-funded. This gets checked, and if everything is fine, the next settlement cycle starts. If not, then we have the trade termination procedure in place, which is actually up to the implementation of the software or the software version of how both counterparties agree on, which then applies in terms of termination. So, surprisingly for us, PwC did a white paper in October 2023, actually pointing to the same features this product actually has. So it's not about digitizing processes or something. It reduces funding costs, operational costs. It even has might have an impact on the capital side. So capital requirements may lower because this product shows no no counterparty risk anymore. So looking at the wholesale euro, the nice thing about this product, it's payment only, so no asset chain is needed. Yeah, we can run this as a full decentralized application. You can imagine like an algorithmic clearing protocol being installed, often suitable payment chain, for example, and then it would unlock its full potential because it could directly interact with default-free digital central bank money. The current implementation is being done with a SEPA network, yeah, but this might be not scale enough. But for the last two proof of concept which we traded, we did use this trigger. But surely looking at the exploration phase of the digital euro now, we could deploy, as I said, this SDC product on a central bank payment chain with counterparties operating a node. And for that, the SDC code has been published. This is fully open source. You can download it. It's published as an ERC6123 and could be easily reused on this infrastructure. So this was the part of how to decentralize the post-trade processing for a derivative. And now I would like to hand over to Christian, who will show you the same for the security side.
So thank you. My name is Christian Fries. And yeah, the smart derivative contract is actually about getting rid of superfluous processes, yeah, thus reducing costs, and also getting rid of intermediaries. Yeah, so no collateral process, yeah, no collateral management unit. And another aspect where this is the case is DVP, delivery versus payment. Yeah, maybe you all know this. I have a small overview. And the SDC is also a kind of delivery versus payment that removes intermediaries. So what's the delivery? What's the payment? Well, the delivery is that you have an asset that has a claim that has, due to a market move, generates a claim for a margin call. And the payment is the settlement of this margin call is cash. The nice feature about the SDC is that you can do this on a single blockchain infrastructure because there's just booking of cash. Yeah? The claim is created by the valuation model. If you have delivery versus payment, that you have a payment in cash for an asset, you maybe have two infrastructures, two blockchains. One is managing the asset, one is managing the payments, and you have to create a secure link. Yeah? The delivery versus payment, yeah, the guy comes with the money and would like to collect the asset, and you have to ensure that everything is atomic in a certain sense. So there is an idea hash link contract that has similarities to this, and Banca d'Italia wrote a paper that improves this idea. And let's have a look at these two ideas, and then let's have a look at what we propose. So we propose an even leaner, just a small improvement, leaner way of doing this that fully removes intermediaries. So this is the hash time lock contract. So you see, time is running vertically down. Yeah, so these are kinds of swim lanes. You see the participants, the buyer, the seller, the DLT managing the asset. Yeah, so controlling the asset, and then some API to the payment system. Yeah. The first step is that the seller generates some secret key that later allows to obtain the asset, if the buyer knows this secret key. So this is called here, in this context, it's called pre-image. And from this pre-image, only a hash is generated. And this hash is then passed to the DLT, to the asset chain. So the asset chain can check, is anyone presenting the secret to me? Okay, then he gets the asset. Also note that smart contracts have the nice feature that they know who is presenting something to them. Yeah, so the function knows the caller. So he can check if the buyer is coming to him, and he can check if the buyer knows the secret pre-image. So this is then locking the asset. So that's the first step. And you see there in this locking here, there's a transfer from the seller to the smart contract. So the smart contract is locking the asset. This is locking the asset. Then the second step is creating the payment. So the buyer is moving his money to the smart contract on the payment chain by talking to this API. And this API can then verify that this has happened, and the seller can check this, so he gets an okay. So this is this okay here. And then the seller tells the payment chain, okay, the money is locked. Here is the pre-image. So this is the atomic operation. The money is moved to the seller. The pre-image, the secret key is moved to the buyer. So this is actually here the atomic step that ensures the delivery is paid. And then the buyer can collect the asset. So in the title you see can be compromised here. So there are small issues with this protocol. So we want protocols without intermediaries. First one is there is a kind of timeout here. So the seller needs to collect the fund, the money, and he's actually free to choose when he does this. So there's some kind of option. And then the buyer needs to collect the asset within a certain time. Because if he does not collect the asset goes back to the seller. And you can think of a kind of denial of service attack on the buyer. So just prevent that the buyer collects the asset, then the seller has the money and the asset flows back to the seller. Okay, so the improvement is, so you have a trade-off, longer timeout increases safety but decreases efficiency. The improvement is to get rid of this timeout. And this was here proposed by Banca d'Italia. And what they do is actually you now have two secrets. One secret is the one where the buyer can collect the asset. The other secret is where the seller can collect the asset. So these two secrets are now handled by some kind of API. So there has to be a central service that manages these secret keys. Okay, going a bit quicker, the API then manages access to the payment system and ensures that the payment has been made in the correct way, and then it distributes the corresponding secret key, either to the buyer if everything was okay, or to the seller, if it was not okay, and the seller has the right to reclaim the asset. The issue here is that we have some central API that needs to maintain state. In nerd speak, maintaining state means that the API has to remember something about this transaction. And you also see that buyer and seller talk to this API. So this is not decentralized. This is maybe a problem. What we propose is slightly different, quite similar. So we have seller, buyer, and then we have two smart contracts. One smart contract on the asset chain, other smart contract on the payment chain. And the first thing you should observe is that buyer and seller only talk to the smart contracts. So this is very nice. No API involved. Let's quickly go through this. The encryption of these secret keys is done by the buyer and the seller. So the seller encrypts the secret that is later used by the buyer to claim the asset if it was successful. And the buyer is creating the secret key that can be used by the seller to reclaim the asset if something has gone wrong. So these keys are then encrypted and passed to the asset chain and payment chain. So here you see they store the keys. So the chains can verify that the correct secret has been presented. And then comes just a single, very small transaction. So first note that the guys only talk to the DLT. And the single transaction is that if the payment is successful, the buyer gets the secret to claim the asset. If it is unsuccessful, the seller gets the secret to reclaim the asset. And this is done by the DLT just talking to a single stateless oracle that decrypts the key conditional to success or failure. So the nice thing is that this is completely stateless. This payment system does not need to know anything about the transaction. Okay, this is our proposal, and the idea is, again, like in the SDC, to remove intermediaries. We have a white paper, and we also propose this as a standard to the ERC 7573. Let's conclude with a small remark on open standards. So we are two nerds, maybe from the bank, and sometimes we hear, okay, what's the product you like to sell? So actually, we don't like to sell any product. This is completely open source. The mission is that we would like to propose a standard that removes frictions in the banks that do not require any additional intermediary. So the benefit is just by removing costs. So if you think of distributed ledger technology, this is enabling full disintermediation. We have distributed data storage, distributed code execution, distributed representation of digital claims. But then there's the absurd thing that you have some software infrastructure provider providing this software. So what's the point now? So now I have a new software that uses this distributed thing, but actually it's not distributed. So we would like to have a joint development of open source based financial protocols that enables us to speak to each other, like in the internet or email. I mean, you just install an email client and you can talk to another email client from another company because all these protocols are completely defined. Maybe we could expect to establish a work group format that drives this development of common standards. So we are proposing here